Hi, and welcome to your notes on rate of change any which way. During these notes, please pause at any time you need to write down information. Let's get started. We're going to use the information from the scenario to complete the table, graph, and equation that represents the rate of change. Sarah and her dog walk at a rate of 2 miles per hour on their evening walks. If we want to create a graph or an equation, we first must complete a table. So as we look at our table, we need to identify the X as the hours and the Y as the miles walked, because time first passes before they can walk miles. At 0 hours, they have walked 0 miles. At 1 hour, they have walked 2 miles. Please pause your video to complete your table. This is the table you should have completed. Please check your answers. Now that we've completed the table, we can also fill in our graph at this time. One of the points we will use will be X is 0 and Y is 0. This is the origin. Since our graph passes through the origin, we know that we have a multiplicative relationship. Our next point will be X is 1 and Y is 2. That means we'll move to the right 1 and up 2 from the origin. Please pause the video to graph your table now. Here's the table here's the graph from your table. Notice we can extend our line into the negatives, but since our scenario is about Sarah and her dog walking, we would not really have any negative values of time or distance. Our rate of change could be found by finding the delta y, which from 0 to 2 would be positive 2, and our delta x from 0 to 1 is a positive 1. So my rate of change would be delta y over delta x, which is 2 over 1, and my equation is y equals 2x, because the 2 represents the miles per hour that Sarah is walking. So our rate of change will be 2. If we look at the question on the back, or underneath, it says how many miles will Sarah walk if her and Sam travel for an hour and a half? We take our equation we found from the front page, y equals 2x. We're going to replace the x with 1.5 because x represents hours. Once we multiply 2 times 1.5, we get y equals 3, which tells us that Sarah and Sam will walk 3 miles if they walk for an hour and a half of time. How long will it take them to go 5 miles? We're going to use our same equation. This time the 5 we're given represents miles, so we're going to replace the y value. This is a one-step equation. The opposite of multiplication of 2 is to divide by 2. We divide both sides by 2, and we come up with x equals 2.5. This means it will take Sarah and Sam 2.5 hours to walk 5 miles. If Sarah and Sam walk 14 miles in a week, or at most 14 miles in a week, how many hours have they walked? This time we're going to set up an inequality. Our rate of change of 2 times the number of hours they walk has to be less than or equal to 14, because they walked at most 14. 14 is the most miles they walked. This is a one-step inequality. The opposite of multiplying by 2 is to divide by 2. I divide both sides by 2, and I get x is less than or equal to 7. This means it will take Sarah and Sam less than or equal to 7 hours to walk at most 14 miles. As we look at our next problem, we're talking about Anna, who has lost weight, and we want to use the information in our table to complete the graph, scenario, and equation. Since we are already given our table, we can take the x of 1 and the y of 1.5 and plot it on our graph. We'll move right 1 and up 1.5. We will then move right 2 and up 3. We could move right 3 and up 4.5. We can say that Anna loses 1.5 pounds per week. The 1.5 is coming from the delta y of 1.5 divided by the delta x, which is 1. Since we have determined 1.5 to describe the pounds per week, that will also be y equals 1.5x. That tells us that our rate of change is 1.5. How much weight will Anna lose in 8 weeks? We're going to take our equation, y equals 1.5x. The x replaces the number of weeks, so 1.5 times 8. We know that Anna will lose 12 pounds. How long will it take her to lose 15 pounds? We're going to take our same equation. The 15 is representing pounds, or the dependent variable of y. 1.5x is equal to 15. The opposite of multiplication is division, so both sides will be divided by 1.5. X equals 10. This means it will take Anna 10 weeks to lose her 15 pounds. How long will it take Anna to lose more than 18 pounds? We still have 1.5x, and our pounds is 18, but this time we want to set up an inequality where 1.5x is more than 18. I will divide both sides by 1.5, and my answer is 12. This means it will take Anna more than 12 weeks to lose 18 pounds. More than 18 pounds. As you flip your sheet to the back side, our first question gives me an equation of y equals 1.5x. In an equation, your rate of change is called the coefficient, which is the number or fraction in front of the variable of x. So this equation has a constant rate of 1/2, or 0.5. I will use this information to fill in my table. If I use a negative value of 2 for the x, I take half of -2, which is -1. If I take 0 for x, half of 0 is 0. Please pause the video now and fill in the rest of your table. Here's a table full of values. I can use negative values for x because I am just given an equation or a verbal situation. My 1/2 does not have any meaning for a real life problem, so my values for x can be negative. So as I look at my points, I have a -2, -1. So I'll go to the left 2, down 1. This does go through the origin at 0, 0, so it is multiplicative. The point 2, 1 means go right 2 and up 1. My rate of change will be 1/2 or 0.5. As I answer the questions underneath, what is the value of y if x is 20? I take my equation, plug in 20 for x, half of 20 is 10. Find the value of x if y is 17. This time I am given the value of y, so I will replace the y with a 17. And I am the opposite of multiplying by 1/2 is to multiply by 2. And when I do that, I get x equals 34. This means that half of 34 gives me 17. If I use the inequality of 1/2 x is less than 31, again, I multiply by 2 on both sides. Any value for x that is less than 62 will give me a y value less than 31. Here I am going to take the points from the graph to fill in the other parts. So I have the point 0, 0. This is multiplicative. I also have the point -1, 3. I have the point -2, 6. There are 1, 2, 3, 4, 5, 6, 7 points on this graph. I really only need a few. Pick some points off of the graph and fill in your table. Your table may look similar to mine. -2, 6, -1, 3, 0, 0, 1, 3, and 2, -6. Use this to help you find your rate of change by finding delta y divided by delta x. Please pause the video to do that now. As we fill in the verbal, we can say as the x value
There's a ton of junk food in the...
decreases by a value of 3, the value of x increases by 1. Or we could say that as the y increases here, the x value decreases because my line not only goes left and up, but down and right. My rate of change is going to be -3, so y equals -3x. As we answer the questions, what is the y value if the x value is 14? We take our equation, we replace the x with the 14. -3 times 14 is -42. Find the value of x if y is equal to -33. This time I am given the y value. I will replace y with -33. I have a one-step equation. The opposite of multiplying by -3 is to divide by -3. I get x equals 11 because -33 divided by -3 is positive 11. For what value of x is y greater than or equal to 20? So I set up my inequality. I will divide by -3. Since I am dividing by a negative number, I must flip my inequality, and I am left with x is less than or equal to -6.6 repeating, or -6 2/3. Please bring these notes with you to class on Monday. If you have any questions, we will talk about them then. Feel free to go back, watch the video again, and remember to pause anytime you need to write something down.